No. The first question sent to you was define power. So
Work done over time.
power equals to work done divided by time taken. So power is work done divided by time. Show that the SI base unit of power is this. So power equals to work done is force multiplied by distance divided by time. I asked you to remember the unit for force, the SI base unit for force, which is, and even, excuse me, if you don't remember it, you know that F equals to ma, mass times acceleration. So it is mass, kg, times acceleration, meter per second square, times meter divided by second. So it will become kg, m and m square, s minus 2 divided by s minus 3, hence shown. Now, a body radiates energy. The power radiated by the body is given by power equals to K times A into T4. T is the thermodynamic temperature of the body. T is the temperature, so unit for temperature will be Kelvin. A is the surface area, so its unit will be meter square. And K is a constant. Determine the SI base unit of K. Whenever he is asking you to determine unit of anything, you must make it subject to formula first. So first of all, you're supposed to find K. What is K equals to? It is power divided by area into T4. So even if you got the previous one wrong, you don't know how to find the unit for power, you should know that he has already given you the unit for power. So it is kg meter square per second cube divided by area is meter square and temperature is Kelvin. So temperature power 4 means Kelvin power 4. I hope you can clearly see that I can cancel meter square with meter square. So what I'm
Yes.
left with is kg s minus 3 k minus 4 kg per second cube per Kelvin 4. On the variation of t square and t. Listen, actually, you should know how graph of y equals to x square looks like. Y equals to x square. The graph is something like this, a necklace curve. So here we know P equals to K A T4. So that means that P is directly proportional to T4 or P is directly proportional to square of T square. That means you should expect a graph of y equals to x square and only one half of it, like you will be looking at one half of the curve. So it should be like that, a curve with an increasing gradient. So how many of you got 5 marks in this question? Anyone? No?
Sir, I got 4.
Okay, good. So which part did you get wrong? Graph?
Yes, the graph.
Okay. Now, moving on. The next question I sent was, I guess this one. The drag force, actually, whatever force is, it is a force. So remember, it must be measured in newtons. Acting on the sphere moving through the fluid is given by the expression Fd equals to K rho V square. K is a constant. The density rho is density of the fluid. V is the speed of the sphere. Determine the SI base unit of K. What is the first thing you should do over here? Make K the subject of
K this.
formula. It will K equals to force divided by density speed square. So you will be doing kg meter per second square divided by density is kg per meter cube. Speed is meter per second, and there is a square on it. So I think you can see that the kg can simply be cancelled by kg. So we have meter per second square divided by meter cube into meter square per second square. Okay, so you see that second square per second square can also be cancelled out. So we now have m over m minus 1, which will be m square. Who got this one right?
Sir, me.
No one?
Sir, I got it right.
Oh, good. Soban, did you get this one right? Okay, no answer. Let's see. Okay, moving on. The next question is here. Yes. Define pressure. Pressure equals to force divided by area. Uh, if you're smart, you can see the pattern over here. Look at the question on the left. Define power and then show the unit is this. Look at the question here. Show that the SI base unit of pressure is kg per meter per second square. So can you do that? Pressure equals to force over area. So kg meter per second square divided by meter square. So kg m1 minus 2, m minus 1, s minus 2, hence shown. Now, gas flows through the nozzle, a narrow end nozzle of a pipe. Under certain condition, the mass m of gas that flows through the nozzle is in a short time t is given by. This is mass divided by time k c rho p. So what are these things? He's supposed to explain every single term he uses. He has already explained two. Mass m, it means m means mass, t means time. He's now explaining k is a constant with no units, so k will have no units. C is the quantity that depends on the nozzle size. Rho is the density of the gas arriving the nozzle, so it is density, kg per meter cube. P is the pressure of the gas arriving at the nozzle, so it is kg per meter. per second square. He has not tell you the unit for C. And the reason is because he's asking you to find that. Okay. What do we do when we have to find a unit of something? We make it the subject of formula. So what C will be equal to in this case? C will be M divided by T into K. I could simply ignore K over here, but I will do it in the next step. Density into pressure. So unit of C, unit of mass is kg, time is second, K will have no unit, so we will just simply ignore it. Multiply by under root of density's unit is kg per meter cube, and pressure is kg m minus 1 s minus 2. Okay, it is going to be interesting. Now, kg on the top divided by s into under root kg square, m minus 3, m minus 1, m minus 4, s minus 2. So when we cancel the square root, we cancel the square, and this will become 2. So we will have now kg divided by s, another kg, m minus 2, and s minus 1. So I think you can see s minus 1 cancels with s, kg cancels with kg, and we have m square. So SI base unit will be m square. It is actually the area of the nozzle. That is why it depends on the size of the nozzle. Okay. Now, define resistance. How do we define resistance? So the basic formula that you have already done in previous classes, voltage equals to, I hope you remember, V equals to IR. So resistance equals to electric potential difference across a conductor divided by current through the conductor. So this is how we define resistance. Resistance is electric potential difference divided by current. The potential difference 0.6 volt is applied across a resistor of resistance 4 giga ohm. Calculate the current in picoamperes. I equals to V over R. So 0.60 divided by 4 into 10 to the power 9. 0.15 into 10 to the power minus 9. 150 into 10 to the power minus 12. Minus 12 is taken as pico. So 150 pico amperes. Now that is not relevant over here because you will be doing it later. This is the question that you have to do. The energy E transferred when charge Q moves through the electric component is given by the equation E equals to charge into electric potential, where V is the potential difference across the component. Use the equation as a base unit of potential difference. We have to find unit for potential difference. So potential difference, first make it subject of formula. V equals to E over Q. So E, energy. What's the unit for energy? Kg, meter square per second square, divided by charge, A, S. So we have kg, m2, s minus 3, a minus 1. It should not be a problem because we have already done that a day or two ago. So easy 6 marks over here. I guess we have only one question left now. Let's see. Define force. Rate of change of momentum is net force. Force is actually push or pull of one object on another. State the SI base unit of force. I asked you to remember it, but even if you don't, F
kg
equals to
ms.
MA. Yes, kg m s minus 2. Good. Now, again, he has given you a formula that you don't recognize. Okay, you should not make sense of this formula because you don't know. Similarly, you do not know this formula. You do not know this formula because they are not part of your syllabus. Okay. So in these questions, you have to deal with the formulas that you don't know. Examiner just wants to see that can you apply the knowledge that you have on a new formula or not. Now, the force F between the two charges is provided by the formula Q1 multiplied by Q2 over 4 pi r square epsilon. Q1 and Q2 are charges, so each will have unit AS. R is the distance between the charges, so it is in meters. Uh, Epsilon is a constant that depends on the medium between the charges. Use the above expression to determine the SI base unit of epsilon. What do we do? First, we make epsilon the subject of formula. So Q1, Q2 over 4 pi r square F. Remember, 4 and pi are numbers. They don't have any units, so they don't participate in the makings of units. So SI base unit of epsilon will be charges. Each charge will have AS. So it will be AS, 4 pi, no units, meter square, kg, meter per second square. So we will have A square, S square, M minus 3, kg minus 1, S plus 2. So we have A square, S4 per meter cube per kg. A weird looking unit, but it is the SI base unit of epsilon. Is it okay? Yes, it is. Now, any questions?
No, sir.
No, sir.
Okay, from tomorrow we'll be starting new chapter about um, errors and uncertainties. This is it for today. See you people tomorrow. Thank you very much.
Allah Hafiz, sir.
Allah Hafiz.
Allah Hafiz, sir.
Allah Hafiz.